we go. It says find the find the geometric mean. All right. So find the geometric mean. Do you remember the geometric mean? Okay. So it's where you put that proportion. Get Kenny.
Okay. You gotta put 2x. You gotta put 2 over x. X
over 2.
Yeah, you're right. It doesn't matter which way you do it, but we usually do it like this. So we'll put the x's here, and then what goes in these two spots?
2 and 8.
2 and the 8, right? And then what do you do here to find x? Cross multiply. So that's x squared equals what? 16. Now look, how do you get rid of that squared? We've talked about this many, many times. Square root both sides. Now I don't have to show the square root. I know it goes away, so I just cross it out. But what do we have to do to this side? Square root this side. Now look, don't just leave it like this. It's 4, right? So the square root of 16 is just 4. So that's how you should write it, like that. Okay. I'm not gonna be real picky. If you kept it the square root of 16, I'll be honest, I'll probably give it to you. I shouldn't. Okay. I should be a tough teacher and stand my ground and not accept that. But I'm not tough. I'm a wimp. So I crumble. That's right.
What?
Okay. What does that got to do with anything? I was wondering myself. I'm glad you told me that because we went over this already.
No, but like when we first got it back.
Oh, we answered questions on this. That's okay. We're putting. Okay, that's right. We're gonna go over it again. Did I record it?
No.
Okay. Well, I'm recording it. All right. Good. So let's do the same thing here. 9 and 36. So 9 and 36. So we cross multiply again. Now look, if you wanted to, you could go 36 times 9, get some big old number, and take the square root of that. But I made this really easy for you so that you can actually simplify this. Now, do you have to get the answer right on the test? No, you don't. But this is a way that you should do it, all right? Because if you take Algebra 2 next year, you're going to have a whole entire chapter on simplifying radicals and square roots, all right? So this is good practice for you. So watch. We take the square root of both of these things. What's the square root of 9?
3.
What's the square root of 36? You multiply them together because they're being multiplied together, and what is that? That's 18. Now, if you would have put 9 times 36 in your calculator, you got some big old number, take the square root, it still would have come out to 18. All right? So there you go. That's your answer. Simple, isn't it? So who cares about the geometric mean? Why does that even help us do anything? Well, it helps us on these next problems right here. So these three, I made this as easy as I could. These three letters right here, X, Y, and Z, are all geometric means. It's just you got to know between which two numbers. So X is a geometric mean between what number and what number. Z is a geometric mean between which one and which one, and Y is a geometric mean between which one and which one. Okay? So let's do Z first. Is that all right? So let's do Z. Even though it's out of order, that's okay. You don't have to go in order when you take these tests, do you? Because I put the nice blocks there. Isn't that nice that I do it that way? Put the nice little blocks there so you can go any order that you want. What I would suggest that you would always do the easiest ones first, the ones that you know how to do. You don't have to start at number 1, all right? These probably are the easiest on this test, but you don't have to start at number 1. Start at the problems that you can do the easiest, and then save the harder ones to the end, and if you have time, you can work on them. So let's do Z first. So Z is a geometric mean. Now you just have to know between what and what?
3.
Between 3 and 9, that's right. This altitude right here is a geometric mean between these two segments, between 3 and 9. That's all you got to remember. Just like you do with the X, right? So Z, so that's a geometric mean. So you're going to put the geometric mean like this, aren't you? X is also a geometric mean. So when we start solving for X, we set it up the same way. Same thing with Y. Okay? So Z is a geometric mean between what and what? Between 3 and 9. So you go 3 and 9. Cross multiply, Z squared. Now watch what I'm going to do. Yeah, you could go 9 times 3 is 27, and it's the square root of 27, but watch how nice this is. Take the square root of both sides. What's the square root of 9? 3. Square root of 3, you just write the square root of 3. That's Z right there. See how easy that is? You could leave it the square root of 27 if you wanted to, but I'm trying to teach you more than just trying to get the answer right, okay? I think it's nice to write it like this. You don't absolutely have to, but I would like you to. Yeah.
How do you know, like, for X or Y, like, how do you know if it's
Because
3 or 9 or, like, the whole thing?
Because we've talked about it. This side, the length of the side of the triangle, one of the legs of the right triangle right here, is the geometric mean between the whole thing,
and that little tiny
which is 12, and the side that's next to the X.
Okay.
All right, so that's our rule. Our rule says to find one of the legs of that right triangle, that's the geometric mean between the whole hypotenuse, which is 12. Right? How did I get 12? Just added up the 3 and a 9, right? And the side that's adjacent or next to that side that you're looking for. Everybody got that? So what numbers do we put here and here? 3 and 12. See how easy that is? Now watch this. X squared. Yeah, it's 36, and I know what the square root of 36 is. It's just what? 6. Just like that. It's easy, isn't it? I didn't get many responses on that.
It doesn't really matter which one goes under, or yeah, under or on top, right?
No. It doesn't matter because you're going to go 3 times 12 anyway, right? It doesn't matter if the 12 is here and the 3 was here. You're still going to multiply them together anyway, so it doesn't make any difference. Make sure, though, that the x's are diagonal to each other. Everybody got that? I've had some people put the x on top and the x on the bottom right here. That doesn't work. Right? You got to put the x's diagonal to each other. Now let's solve for y. Y is very, very similar to solving for x. So y is also a geometric mean. So we put the geometric means right here between what and what? Between 9 and 12. Between the whole thing and the side that's next to the y. Just between 9 and 12. So really, to do these problems, the only thing you have to know is which two numbers do I stick in those empty places, right? So this one right here, if I'm trying to solve for this, what numbers do I put in? This one and this one. This one, whole thing, and this one. Y, the whole thing, and the one that's closest to that. Easy, isn't it? Yep. So watch. Y squared equals 9 times 12. I'm just going to show you a little trick. Take 12 and break it down into 4 times 3. Why in the world would I do that? Because I know what I'm going to do. I know I'm going to take the square root, aren't I? To get that. So y is equal to what? 3 times 2, and then what? Square root of 3. What's 3 times 2? 6, square root of 3. So that's what y is equal to. You don't have to do that.
I got a question.
Yes.
Would it be safe to say that, you know what,
Okay.
I was going to say, like, T out of Z is 3 squared, 3, like, would it just be double, like?
No. No, I mean, there's situations where it might be, but yeah, there's no special rule or anything that says that that would be true. Okay. Yep, that's fine. Yeah, they are. He's a jamming kind of guy. Alright, let's do this one. Look at these. Pythagorean Theorem. We all remember Pythagorean Theorem. Oh, I almost forgot. I'm going to be extra nice to you. I'm telling you. You just don't know how nice you have it right now. I don't know. I think I may be... I don't know if I'm hurting you in the end or not, but anyway, I'm going to give you a formula sheet. Formula sheet. I hope I will. I plan on it. So, all the major formulas I'm going to give you. Now there's some things like geometric mean, that's not really a formula. You got to know how to do that. But I'll give, like, this is Pythagorean Theorem. I'll give you Pythagorean Theorem, okay? I may even write SOHCAHTOA down for the trig stuff. I'll probably write down the law of sines and law of cosines. When we do the area, listen, when we do the area, I'll give you the area of the triangle, the rectangle, the parallelogram, all that kind of stuff, okay? So I'm telling you, this is, but again, I don't want you to not study, because you still have to know how to use those formulas. Just because you know the formula doesn't mean that you're necessarily going to get the problem right. Okay? So let's move this up to here, and let's do this problem. Alright, let's take a look. It says determine whether each set of numbers can be the measures of a triangle. So there's actually two parts to this. First of all, we have to determine if that's a triangle to begin with. You can't just take any 3 sides and make a triangle out of it. Alright, there has to be something that's true just to make it a triangle to begin with. So let's see if this is a triangle to begin with. What's our little trick? Kaylee?
Well, this is what I was going to ask. Are you going to give us the formulas for that too, like for us to remember?
I'll probably just give you Pythagorean Theorem. I probably won't say, you know, if it's greater than, I probably won't do that. No, I mean, there comes a point where you got to know something, okay? So I'll probably give you Pythagorean Theorem, but that shouldn't even be a big deal for you, should it? I mean, you should already know that, but I'll put it on there anyway. So how do you know if this is a triangle? What do? You take the 2 smaller ones, and what does it need to do just to determine if it's a triangle to begin with? You need to do what to them? Add them up. So 20 and 30 is what? 50. 50, or that sum, has to be bigger than that third side. Is it bigger than that third side? Yes, it is. So that is a triangle. So we say yes. Now we're not done with that, but we have to determine first of all if it's a triangle to begin with. Make sense? All right, so yeah, that is. What about this one? Is that a triangle? We'll take the two smaller ones. 6 plus 12 is what?
No, it's not.
18. Is 18 bigger than 20? No. So this isn't even a triangle. So right off the bat, what can I say? I can say that it's no triangle. So if it's no triangle, I'm not going to say it's acute, obtuse, or right, because it's not even a triangle to begin with. Okay? Does it make sense? All right, so determine that first. On this one, it's not that easy to add. What would you use on this one to determine it? Calculator. So let's just see if that's a triangle. So the square root of 5, oops, I got to do it the other way, sorry. Square root of 5 plus the square root of 12, oops, 12, okay. Let's see what that is. That's 5.7, okay? So that is 5.7. Now I have to compare that. What does this have to be? This has to be what? Bigger. It's got to be bigger than the square root of 13. Let's see what the square root of 13 is. So the square root of 13 is 3.6. So is this bigger than this?
Yeah.
Yes, it is. So is that a triangle?
Yeah.
Yep, it's a triangle. Now, we just did that to start off, didn't we? What do I hit? That. Okay. So now that we determine which ones are triangles, now we determine what kind of triangle it is. Make sense? So let's take 20, 30, and 40. How do we determine what type of triangle it is? Well, we take, this is the A, this is the B, and this is the C. All right? Well, let's do it in this order first. Let's not go A squared first. Let's go what? C squared. Let's do C squared and compare it. I'll put a question mark here. Compare it to what? A squared plus B squared. Okay? So, if C squared equals this, what kind of triangle is it?
Right.
It's a right triangle. If C squared is greater than these two, it's not acute, it's obtuse. How can you remember greater obtuse? Because an obtuse angle is what?
Smaller.
No, obtuse.
Oh, greater.
It's greater than 90 degrees, isn't it?
Yes.
All right? So that's how you can remember which one's which. If C squared was less than A squared plus B squared, then what kind of triangle is it? It's what? It's acute. How do you remember that? Because acute is less than 90, right?
Yeah.
Okay, so that's what we have to look at and determine. We're using calculators for this. So I put the 40 in here, 40 squared. Leave a blank here and go 20 squared plus 30 squared. And let's see what we get. Let's see what 40 squared is. That's 1600. So that's 1600. Let's figure out what these are. We know what this. What's 20 squared in your head? You can do that. It's 400, right? What's 30 squared in your head? It's 900, right? What's that together? It's 1300. What is 1600 to 1300?
Greater.
It's greater. So what kind of triangle is this? It's obtuse. Does that make sense? It's not hard, is it?
No.
The math isn't really difficult. You just have to know what that stuff means. Please. All right, so we'll just erase all that. All right, so that's good. Now, this wasn't a triangle to begin with. It was no triangle, right? So I don't even have to do that with that one. That's what I just put. I just put no triangle. What about this one? This one looks difficult, but it's really not that hard. In fact, I could do all three of these with no calculator at all, couldn't I?
You get it.
So watch this. What am I going to do? I'm going to go C squared. Which one is the C here? The square root of 13. All right, so the C is the square root of 13. So I take the square root of 13 and square it. Leave a blank right here because I don't know if it's equal, less, or greater than. Then what do we do here? Take the square root of 12 and square it, and then add it to, well, it doesn't matter what order, does it? Square root of 5. Everybody see that? Put a question mark in between here because I don't know if they're equal, less than, or greater than. Let's see what it is. This is actually very, very easy. Don't let the square root mess y'all up. What's the square root of 13 squared?
13.
It's just plain old 13. That's it. All right, you don't need a calculator for that. What about this? What's the square root of 12 squared? It's 12 plus what? 5. 13 is what? That's 17. So 13 is what? Less than 13. So what kind of a triangle is it? And it's an acute triangle. That's all you got to do there. It's really simple. I took a bit of a long time explaining it, but to actually do the problem just takes a fraction of the time that it took me to explain it. All right. Let's get rid of this stuff right here. All right. Let's look at this. Speaking of Pythagorean theorem, look at what we have. We have a right triangle, don't we? Now look, if I remember right, if my recall is coming back to me, I had people trying to do sine, cosine, tangent. Some people trying to do law of sines, law of cosines, all that kind of stuff. No, no, no to any of that stuff. This is much easier because it's what kind of a triangle? It's a right triangle. If I have a right triangle and I know two sides, I use Pythagorean theorem. That's right. So let's do that. Now look, the C is always the hypotenuse, isn't it? Right? So that's going to be by itself. So x squared equals, what do we got? 16 squared plus 33 squared. Now look, get rid of the square root, get rid of the square, sorry, by taking the square root. So we take the square to both sides and we just plug that into our calculator. So let's do that. 16 squared plus 33 squared. Alright, and that gives you that big old number right there. What do we have to do that big old number though? Take the square root of that number. Oops. Why do I always do that? What do I hit when I do that? Oh, I hit the 3 instead. That's what I want right there. Alright, and then that equals 36 point what? Nearest tenth? 7. 36.7. 36.7. That's all there is to it. Now look, most of you got this right, if I remember. Okay, that wasn't that difficult. There was a problem with this one right here. Okay, this is what a lot of people did. All right, my bad. There's the stuff. Okay, I don't remember when I stopped recording because the guys came in to get your books and I stopped recording. Anyway, I think I probably just started. Anyway, there it is. Have fun with that. I'm not doing it again. All right. Anyway, let's just talk about this real quick. 45, 45, hypotenuse. I'll tell you what, I'll write this down. And hopefully I'll have this on my sheet. What do you call that? Formula sheet. So the hypotenuse is what? On a 45, 45. The square root of 2 times what? One of the legs. On a 30, 60, 90, the hypotenuse is... No, the hypotenuse, right, twice the short side. Okay, the hypotenuse is twice the short side. The long leg is what? The square root of 3 times what? The short side. That's how we got the short side right here. If I know the long leg, how do I solve for the short? How do I solve for short? Get rid of the square root of 3 by dividing it. So it's 7 divided by the square root of 3. It's not my answer though, is it? No. I need to find x. What's the relationship between the hypotenuse and the short side? It's double. So if I double this, what's 7 divided by the square root of 3? Doubled times 2. What is that? It's 14 divided by the square root of 3. All right? You should simplify it. It says it right here to simplify it. So we've talked about this before. What's 14 divided by the square root of 3? What do I do? No, not by reciprocal. Multiply by the same thing on top and bottom. You said that? Didn't sound like you said that. Yeah, top and bottom. All right, so look what we get here. We get 14 what? Square root of 3 over, what's that? That's just a plain old 3. That is the answer. I don't recall many people getting that completely right on the test. All right, but that should be the answer. Okay, I'm telling you right now, I'm not going to be quite as nice and easy on the final because I've talked about it. I've shown you how to do these problems. Okay, I want them. If it says exact and simplify, if this is on the final, then I want it exact and simplified and no decimals. So this will be the only possible answer. This will be the only possible answer, and this will be the only possible answer for those problems right there. Okay, makes sense? And I am going to stick to it. All right. So make sure you understand that. All right. So all we have to go through now, and this is what you're responsible for watching on YouTube, is basically 14 to 20. Okay, I'll do that in 6th period today, and there you go. All right, we good with that? All right, please make sure you look at the videos. The quiz is going to be on there as well. All right, so there you go.